Hello and welcome to the Bearded Math Man's YouTube channel. Hey, in this video what we're going to be talking about are the special right triangles that are used in trigonometry. So this is Trigonometry Introduction Part 2. Let's go ahead and get to it. There are two special right triangles that we use in trig. One is an isosceles right triangle. It's a 45, 45, 90 like you see here. Now, we know that the Pythagorean theorem is true for all right triangles. So what we're going to do is we're going to apply the Pythagorean theorem so that we can see the relationship that exists in an isosceles right triangle between the two legs, which are the same, and the hypotenuse. Because what happens is, it doesn't matter how big or small the triangle is. If it's an isosceles right triangle, this relationship is the same. And that's kind of one of the key principles or the fundamentals behind what makes trigonometry work anyway. So let's go ahead and do it. We have a squared plus b squared equals c squared. C, of course, is the hypotenuse. A and b are the legs. Now, in this case, because it's an isosceles right triangle, that means the two base angles are both 45, but the two sides are also the same, so they're both a. So what we end up with is a squared plus a squared equals c squared. Now, yeah, of course, you could have said that that side was b, but either way, they're the same. So let's go ahead and manipulate this a little bit and see if we can solve for a. So what we're going to do, a squared plus a squared is 2a squared. We divide both sides by 2 and take the square root. What we end up with is that a equals the square root of c squared divided by 2. Now, we can simplify this a little bit. The square root of c squared is just c. So a is equal to c divided by the square root of 2. Now, I don't know if you ever learned how to rationalize the denominator, but very briefly, what it is you have a fraction. If the denominator is irrational, like the square root of 2, that makes math a little tricky. And so what we want to do is we want to rewrite this in a way so that the denominator is rational. So what we're going to do is we're going to multiply by the square root of 2 divided by the square root of 2. Now, a number divided by itself is 1. When we multiply something by 1, its value doesn't change. So this is just 1, but the reason we're multiplying by the square root of 2 over the square root of 2 is because the square root of 2 times the square root of 2 is just 2, which is a rational number. So c divided by the square root of 2 is the same as c times the square root of 2 divided by 2. Same exact value. So what we end up with is that the leg, the short side, is equal to the hypotenuse times the square root of 2 over 2. And it doesn't matter how big or how small that triangle is. No matter what the hypotenuse is, the legs are that number times the square root of 2 divided by 2. So if we had an isosceles right triangle and the hypotenuse was 15, well, then the legs would be 15 times the square root of 2 divided by 2 each. But if we had a right triangle, it was isosceles once again, and we knew that one leg was 7, well, the other leg's going to be 7. And then can we figure out what the hypotenuse is using this? Well, eventually you should be able to, but maybe right now it's a little confusing. So we're going to apply the Pythagorean theorem. So 7 squared plus 7 squared equals 49. Equals c. So 7 squared is 49. 49 plus 49 is really 98. However, we're going to have to simplify that. So it's easier to say it's 2 times 49 because the square root of 49 is 7. So 7 root 2 equals c. So no matter what, this property holds true. Now, whatever this hypotenuse is, the legs have to be that times the square root of 2 over 2. So let's see if that's true. Let's see if 7 root 2 times the square root of 2 over 2 equals just 7. So 7 times square root of 2 times square root of 2 over 2. Well, square root of 2 times square root of 2 is 2. Divided by 2 is 1. It's just 7. It works no problem. So here's the deal. No matter what this is, no matter what the hypotenuse is, the legs are that value times the square root of 2 over 2, and boom, we're done. So this is the property that you have to really, really understand, especially when we start getting into the unit circle, and especially when we start doing trig that involves situations where you're not allowed to use a calculator. You have to know this triangle, the isosceles right triangle, and the other. So the other is a 30, 60, 90. We're going to approach it with the same concept, but in a slightly different way. So here I'm going to give you all of the sides and the relationship, and we're going to verify that it's true. So with the other triangles, just like you see right here, a 30, 60, 90 right triangle. And the relationship for this triangle is that no matter what the hypotenuse is, the short side is half of the hypotenuse, and the long leg, the longer side, is the short side times the square root of 3, or the square root of 3 over 2 times the hypotenuse. Now, one of the trickier things to do with these kinds of triangles is actually to figure out which is the short side and which is the long side. Now, there's a consequence or a value that's known in the triangle inequality theorem that says that the shortest side is going to be opposite of the smallest angle. And so this right here is the shortest side. It is opposite of the smallest angle. That makes the other leg adjacent, and the hypotenuse is also adjacent, but we never refer to the hypotenuse as adjacent because the hypotenuse is the longest side. It's opposite of the 90-degree angle. And if you're dealing with a right triangle, well, 90 degrees has to be the largest angle. So this is the largest side. It's opposite of the largest angle. The middle side, the long leg, is opposite of the 60-degree angle. That makes the short leg, or the short side, adjacent, and the hypotenuse is also adjacent. So anyway, let's go ahead and verify that this is true using the Pythagorean theorem. So if we have 1/2 squared plus square root of 3 over 2 squared, that has to equal 1 squared. 1 squared is, of course, 1. 1/2 squared, 1 times 1 is 1, 2 times 2 is 4. Yeah, square root of 3 times square root of 3 is 3. Just plain old 3. You could say it's a square root of 9 and then simplify that, but square root of 3 squared is just 3. 2 squared is 4. 1/4 plus 3/4 does equal 1. So this is true. This works, and this is how it works no matter how large or how small the 30, 60, 90 right triangle is. And again, you have to know the isosceles triangle. You have to know the relationship between the sides and the hypotenuse of a 45, 45, 90, and you have to know the relationship between the sides of a 30, 60, 90 right triangle, and you have to have those rock solid. So let's see an example of what this might look like. Let's say we're given a triangle like this, and we're asked to find the missing side and the two angles. Well, the thing you have to notice is that we have a right triangle, and this side is shorter than 5 root 3 because 5 is shorter than 5 times the square root of 3. You also have to notice that this longer side is the short side times the square root of 3. That makes this a 30, 60, 90 right triangle. And if you remember, the short side is half of the hypotenuse. So 5 is half of what? Well, 5 is half of 10. There we go. Now the angles. Remember, the smallest angle, which is this one, is going to be opposite of the shortest side. This triangle is a little exaggerated to really strike the point, but when it's on paper and it's really a 30, 60, 90, sometimes it's really hard to figure out which is the 30 and which is the 60. So again, the 30-degree angle is the smallest angle. It's going to be opposite of the shortest side, and the 60 is going to be the middle-sized angle. It's going to be the larger of the 30 and the 60, and it's opposite of the longer leg. And there you go. So now, let's introduce something that's going to play a huge role when you start to learn about the unit circle. Let's talk about a coordinate plane. You have your x-axis, which is horizontal, your y-axis, which is vertical. You've got your origin. And let's go ahead and put an isosceles right triangle right here so that one vertex of the triangle is at the origin. And let's see if we can figure out what the coordinate right here is. Now let's go ahead and say the hypotenuse is a distance of 1. And now we have to figure out what is the x-coordinate and what is the y-coordinate. Well, the x-coordinate is going to be the square root of 2 over 2 because no matter what the hypotenuse is, the legs are that value times the square root of 2 over 2. So the y-coordinate is going to be the same. The distance from the vertical distance is the square root of 2 over 2. The horizontal distance is the square root of 2 over 2. So our coordinate right here would be square root of 2 over 2, comma, the square root of 2 over 2. And so this kind of just introduces how we're going to use the coordinate plane and the isosceles and the 30, 60, 90 right triangles, the two special right triangles, to construct a unit circle, which is going to come in the next video. So let's summarize what we have here so far. Do you understand what makes a side adjacent or opposite of an angle? opposite means away from, and the hypotenuse and the other side that are next to it, they join and make a point. That is adjacent. So the two sides that are next to the angle are adjacent. The side that's away from is called opposite. Now, do you know how to identify a triangle? Do you know how to identify if a triangle is a special right triangle or not? Well, you got a couple ways. If the two legs are the same, then it's isosceles, and whatever the hypotenuse is, those legs are going to be the distance of the hypotenuse times the square root of 2 divided by 2. If, however, you have the other right triangle, special right triangle, the 30, 60, 90, well then the short side is going to be half of the hypotenuse, and the long side is going to be the hypotenuse times the square root of 3 divided by 2. That's how you can tell. Now, do you know how you could use those values to solve one of those triangles? Well, that's what we did an example of, and that's what you're going to try when you do the practice problems that are right here. Now, I've got a list of notes and some practice problems that I run you through in paper on a text document that you can find on my website. I'll leave a description I'll leave a link in the description below. My website is thebeardedmathman.com, and you can find all kinds of materials there, but I'll put a link specifically to notes and practice problems that pertain to the information shared in this video, so you can practice it, so you can understand it, so you can get it rock solid. Hey, if you have questions or comments, leave them below. I would love to hear from you. If you like the video, give it a thumbs up. Please subscribe and share. Once again, my name is Philip Brown. I am the Bearded Math Man. I hope this video has been useful and helpful. Until next time, I hope you have a great day.